a Ros2 service. As we did for Ros2 topics, let's start with a real-life analogy. I will make an analogy with an online weather service. Here again, this is an analogy, so the point is to make things simple enough and to focus on understanding Ros2 services. Let's say we have a weather service online, which can give us the local weather after we send our location. Now, imagine that you are behind your computer and you want to get the weather from this service. You, on your side, the client, and the weather service online is the server. You will be able to access the server through an HTTP request with a URL. You can think of the HTTP URL as a Ros2 service name. So, first of all, your computer will send a request to the server. The request will contain a message. Here, we send our location. The server will then process the request and send a response. The response will also contain a message. Note that in order to communicate, the request sent by the client must be a location, or else the server will not be able to process the data. And the server must send back a weather data, otherwise the client will not understand what the response is. Okay, we now have one client and one server communicating through a service. But what if we have multiple clients? Well, that is not a problem. All clients will send a request containing a location to the server through the HTTP URL. The server will then process the request and send back a response to each client. However, note that you should not have more than one server for the same service. So here, you can see in this example, we have 3 different computer nodes and one node for the weather service. The HTTP URL can be seen as a Ros2 service name. The computer nodes contain a service client. This service client will call the Ros2 service and send a request with a location. On the other side, the weather service contains a Ros2 service server, which will process all requests and send back a response through the Ros2 service. Again, all clients and the server inside nodes are not aware of each other. They only see up to the Ros2 service interface. Now, let's see another example, this time dealing directly with robotics. This example can be a part of a real Ros2 application. So let's say that you have one node in your application which is controlling an LED panel. The node is dealing with the hardware to power on and power off the LEDs. Of course, you want this node to be able to communicate with the outside. For example, other nodes could ask this node to power on or off a specific LED. In this case, you create a Ros2 service named setLED, for example. Inside the LED panel node, you create a service server for this Ros2 service. Now, you have another node dealing with the battery, for example. One of the functionality is to check if the battery is low and to notify the user when this is the case. To do that, the battery node will contain a service client for the setLED service. Imagine that the battery is going low. When it is detected, the battery node will send a request to the Ros2 service. It will send an LED number and a state. The server, which is the LED panel node, will expect to receive that kind of information. If the data structure is the same as expected, the node can process the information and, as requested here, power on the third LED. Once this is done, the server will send back a response. This response here will contain a success flag. During all the service process, the battery node is waiting synchronously or asynchronously. Upon reception of this response, the battery node knows that the requested action was successfully or not successfully done. And that's it. The communication is finished. The server is still up and waiting for new requests. Later on, after charging the battery node detects that the battery is now full. It will then decide to send a new request to the setLED service to power off the third LED. The server receives this request, performs the operation, and sends back a success flag. The communication is done. Alright, that's it for the example. You should now have a better idea of what Ros2 services are and when you should use them. So to recap, a Ros2 service is a client-server system. It can be either synchronous or asynchronous. Also, a service is defined as a name and a pair of messages. One message is the request, the other one is the response. As for nodes and topics, you can directly create service clients and servers inside Ros2 nodes using, for example, the RCL-CPP library for C++ and the RCL-Pi library for Python. Finally, and this is an important point, a service server can only exist once, but can have many clients. And basically, the service will start to exist when you create the server. To conclude, you can see that services offer a nice complementarity with topics. Topics will be used for unidirectional data streams, and services will be used when you need a client-server architecture. Let's now create a service server so you can practice as soon as possible. We will create a service server in Python that will take 2 numbers as a request and return the sum as a response. So a service is defined by 2 things, a name, which is a common interface between nodes so they can easily find the service, and also a service type. And we will see later how to create your own custom service type, but for now we will use an already existing one that you can see with Ros2 interface show. So Ros2 interface show will show you any kind of interface, and you already saw messages with topics. So a message for a topic or a service definition for a service are both interfaces in Ros2. So we will go back again to our example interfaces, but this time instead of MSG, we will go to the SRV folder and check the add to int service. So you can see here 4 lines, okay? And the first 2 lines here, A and B, are both integers, and int64 is the primitive data type for that integer. So this is the request. The request contains 2 fields, A and B. Now we have 3 dashes. For every service definition, we have 3 dashes, which is the separation between the request and the response. And the response here is one integer only, which name is sum. So as a client, you will send A and B, and as a server, you will receive A and B, process the request as you want, and return a sum. So let's use this service definition here, and in the next section, you will learn how to create your own service definition. We will go again in our Ros2 workspace source directory and in our Python package to create a new file, add to int server.py and make it executable. We can now edit the file from here, so it's empty. We will use the template again, and let's name it add to int server node add int server. So our constructor is now ready, and now let's add a service server inside the constructor. And we will need to import also the service type. So from example interfaces.srv import add to ints. Okay, as we already used example interfaces package before, it's already here with a dependent tag on the package.xm. So we don't need to do that again. So let's create our service server here. Self server, we create a server variable and self create service. Okay, so again, you can use the create service from the node class directly. And we need to give 3 arguments. The first argument is the service type, so add to int. The second argument is the name of the service, add to int here. And the third argument will be the callback function. So the callback function is required here because when you send a request, you need a function, of course, to process the request and return the response. Just a quick note about the service name here. It's usually a best practice to put a verb, okay, as a name. Here it's add, a verb plus maybe an indication of what you are doing. So here the verb is add, and what are we adding? We are adding 2 integers. Because services usually are used for actions and computation. So you will have a service name like compute something, add something, do something, trigger something, etc. And we will add our callback function here. So we create a new function inside the class callback add to int. And usually what I do is when I create a callback for a service, I simply write callback and then the name of the service. So it's easy to remember. And we will get 2 parameters here, right? The request and the response. So that is the request object containing the A and B fields here, and the response will contain the sum field that we need to actually fill. So that's what we are going to do. Response.sum is equal to request.a plus request.b. Okay, as we did for the subscriber with topics, we can directly access the fields directly with request.a to get A, request.b to get B, etc. Okay, so that's quite easy here. And we will need to return the response object. Okay, if you forget to return the response here, you will get an error when you try to call the service. It will get to that point, but then here you will get an error. And now let's add the callback here. So callback add to int. I will do some auto formatting. Great. So our code is now ready. As you can see, it's quite simple. Just one line create a service, and then we have a small callback function. So to recap, here we create a service directly from the node object. We give it a type, a name, and a callback. In the callback, we fill the response object from what we get from the request object, because here we are doing a computation, and we return the response. Let's actually add a log here, self get logger. So it will be easier to see what's going on. And we will just print the result of the computation. So request.a, let's say plus request.b is equal to and plus the response.sum. Okay, so when the callback gets called, we will also see from the server side the result of the computation. And now, before we can actually run the node, we will add it here. So we will install it. So add to int server. So this is the name of the executable, my Python package dot server and main function. So now let's build package with colcon build packages select and my Python package. Okay, source bash rc, and let's run the node Ros2 run my Python package. Let's press start twice. As you can see, we start to have a few nodes here, and we have the add to int server, and it's not printing anything. Maybe we can add just a line here, self get logger info add to int server has been started. Okay, so I always do that. So as you can see here, maybe it's stuck here or something went wrong, but you don't actually know. So let's do that, and we will use the symlink install also. So we don't need to compile again to modify the file. And now we have add to int server has been started, so we know the server is up. And now we will need, of course, to write a client for the server, but we can actually test the server directly from the terminal. So if you do Ros2 service list. So Ros2 service is another command line tool with Ros2, okay? And we'll see more details about that later in this section, okay? So you have the service list, and as you can see, we have services here for the node add to int server. Those are the services for parameters that you already saw when we did the Ros2 node list. We can see add to int server, Ros2 node info add to int server. We have the, actually I will put it like that. So we have already the services here that you saw before, okay? But the one that we will be interested in is the add to int server here. As you can see, if we do Ros2 node info, we see that we have the add to int server with the example interfaces as the add to int service type, okay? And this is a service server. And with the Ros2 service, we will be able to call the service. So Ros2 service call, you can directly put the service name. So add to int. Okay, you can press tab here to autocomplete the type. So Ros2 service call name of the service, type of the service, and then you need to give a request. So to give a request, we will do that with curly braces, and we have A, which is let's say 3, and B, which will be 4. We press enter, and okay, what happened? In the server side, we can see 3 plus 4 equals 7. So we have the log, which means that the callback here was called, and this log line was executed. And then from the client in this terminal, we have the response, and the response is, as you can see, example interfaces srv @2int response with a field sum, which is 7. And as you can see here, everything is possible because of the rclpi.spin for the node, okay? When you start the service, it actually doesn't do anything, okay? And when you start spinning the node, it will allow the node to be alive and to trigger any callback for this service here in particular. So you can call it multiple times, you can call it with multiple, you can change the arguments here, okay, to see that it works. And now we will see how to create a code for the client. Two steps. First, without OOP, object-oriented programming, and then with OOP. So let's go inside our Python package again. Okay, and we create add to int. So this time it will be client, and I will use no OOP here, and you will see why a little bit later. And let's create add to int client. That will be the OOP client. So we mark those two as executable. Client no OOP. Okay. So now let's edit those files. Okay, so I will just use the template for this one, but actually I will remove that, and we will create simply a node object, node with name add to int simply no OOP. Okay, so and we don't need that because we'll just use this main as a script. Okay, so just like you run the node, it will call the service. Okay, create a client, call the service, get the response, and then it will exit. So basically that is the same thing as what you did with Ros2 service call in the terminal. So first of all, of course, we need to import from example interfaces.srv. We need to import add to int. Okay, we need to import the service definition, which is exactly the same as for the server. Okay, if those are not the same, then of course it will not work. And the first thing we do is to create a client. To create a client, we will use directly the node.create client. Okay, so here we don't use self because it's not a class. We use the node object we've created here. And again, you create a service with create service, and you create a client with create client. Okay, it's not that hard. We give the type add to int, and we give the service name, and the service name should be exactly this one, add to int. Okay, so the client is now created, and now we'll be able to create a request and send the request to the server. But before we do that, what we can do here is to wait for the server to be up. So let's say that you run the client and the server node is not up yet. Then if you send a request, it will fail. So what you can do is wait for the server. So why not client? Wait for service. So you have a nice function in the client object, and you can add a timeout. So if you don't add any timeout, it will wait forever. Let's add a timeout 1 second. So after 1 second, the wait for service will exit, and of course we will keep staying in the while. And let's print something, node get logger with 1. Okay, we've used only info before. Here maybe 1 because we are expecting the server to be up and it's not up. It's maybe not an error, but we are waiting for it. So let's put a 1 message, and let's say waiting for server add to int. Okay, so if we let's actually just run this code. So we will add it here, add to int client no OP my Python package and main function. So we install the file, callcon build packages select with my Python package and symlink install. We don't need to do that again. Let's source our bash rc. Okay. And also run my Python package add to int client no okay. So as you can see, we have 1 message in yellow waiting for server add to int. And if I run the server here, Ros2 run my Python package add to int server. Okay, and you can see as soon as we start the server here, the service is advertised, and the client will find the service and will then be able to continue with the execution. And in that case, after that, we have nothing, just shut down and exit. So now we can be sure that after this line, the service is up. So what we can do now is to create a request object, and the request object will be add to int dot request. As you can see, in add to int we have request and response objects, but here we create a request, and we can simply fill request.a equals, okay, let's say 3, and request.b equals 8. And now it's time to actually call the service. So client, you will use call, and you have 2 call functions, simple call and call async, which is asynchronous call. So this is a synchronous call, and that will block until the response is given by the server, but it's not recommended to use by the Ros team because in some situations it may be stuck forever even if the response is given. So we will always use call async, and when you use call async, it will send a request, but then it will continue to, the program will continue to be executed, okay? So here we need, of course, to send the request. And we get something from that. We get a future object. So a future object in Python, if you don't already know that, is an object that contains a value that may be set in the future, okay? So we have the response here, it's already the response, but actually it's empty, okay? And the response will be available when the server has sent the response, okay? So you will call asynchronously the client, sending the request, and you get a future. And now what we will do is rclpi dot spin until future complete. So you have a functionality here to wait for a future. So that's why we don't have RCL by spin here for the node. We will just spin until the future is complete. Okay. And we need to give two arguments. First, the node here. So the node that we've created here, and as you can see, the client is linked to the node. So we need to say we want to wait for this node and the future, of course, to wait for. So here basically you call the server asynchronously and then you wait for the response. So why not call directly synchronously the server? Because as I told you, you may have some errors in some situation or the program will hang. And here, by using that, you can still spin. And if you have any callback, you can still continue executing the callbacks. If you directly use call, all the thread that you are in will be completely stuck. So that is the best practice for a service. And when this line is complete, when this function exits, then we know that we have a response. Or at least the service call is done. Maybe the response failed, maybe the service failed, but we have something. So we will do response equal to future result. So the result function is specific to the future object. And because we may have an exception, we will use a try catch structure here. So we may have an exception. And if we have an exception, we will print an error. So node get logger error. So you have seen 1 here. Now you can see error. So the message will be in red. And let's print service call failed. And you can actually print the exception with that and put the exception in a tuple like that. So if something failed and we can't, and the future result has an exception, then we will see this error with the reason. And now that you have the response, well, you can simply do whatever you want with the response. Here we will simply print the result of the computation. And let's use the log we've used in the server. We use the same. Okay. So I will copy that. Instead of self, we have node. So node get logger info. So a plus b equal the sum. All right. So the client is now complete. Let's actually run it to see what we get. So the server is up. Okay. We directly start the client. And let's see what we have. Okay, so it may wait 1 or 2 times when you start the node, and then you have the log with so from the server and from the client. So everything went successfully. So to recap quickly, first we create a client from the node. We give it a type and a name which should be exactly the same as for the server. Then we can wait for the service to be up. The service will be up when the server has created the service. So from that line, okay, when you use create service, it will create the service, and then the client will know that the server is up. So you create a request. You send the request asynchronously with client.callAsync. Okay, you get a future object, and you can use RCL spin until future complete with the node and the future to get the response. So when you get the response, you get the response with future.result, and you may have an exception here if something went wrong. So you can use a try catch structure to get the exception. More